Hello everyone, this is the next video number 5 in the series of Kinematics 1D. In this video we will talk about acceleration, its types and the question related to this. Acceleration is of two types, just like speed and velocity, average quantity and instantaneous quantity. So how we define this acceleration? For that we need to see the velocity. If the velocity of a moving object or particle changes with respect to time, then we say that the object is being, or body is being, or particle is being accelerated. So there has to be change in velocity. Velocity can be changed either by changing the magnitude or by changing the direction or changing the both. In case of average acceleration, we say is a change in velocity upon the time interval. In case of instantaneous acceleration, we define it as a rate of change of velocity with respect to time. That means dv upon dt. So this d upon dt becomes a rate of change. Acceleration is a vector quantity and its direction is same as the direction of change in velocity vector. Whenever the direction of acceleration and velocity are opposite, we call it to be retardation or deceleration. Now, just like we have understood earlier, velocity depends on position as dr by dt. Similarly, acceleration depends on velocity as a is equal to dv upon dt. Now in case we replace this v by dr by dt, so this becomes d2r upon dt2, or we can replace it by v dv upon dr. For one dimension case, we can write v is equal to dx by dt, where x being the displacement, and a can be written as either of the form as dv by dt or maybe as d2x upon dt2 or maybe x v dv upon dx. So that's for one dimension case. So these two equations, two relations rather, one of velocity and another of acceleration, are basic relations, and they are basic to solve any problem in kinematics. For example, there's example we can deal this example. It says acceleration is dependent on the position, where initially the particle is at x equal to 2 and it is moving initially with 3 meter per second. We need to find out velocity at different time, at different position. So here the position and velocities are to be linked. So this a can be rewritten in the form of v dv by dx. So that's going to be the right definition to choose for. So v dv by dx will become 2x, then separation of variable will lead to v dv is equal to 2x dx, integrating from initial velocity 3 to final v and initial position 2 to final 5. When we integrate, we are going to get left hand side will be v square by 2 minus 9 by 2. Right hand side will become x square, which will lead to 25 minus 4. Simplifying will lead to root 51 meter per second as an answer. So here the definition of acceleration that has been used is v dv upon dx. So in case of such questions, we need to be wise to choose which definition is going to be suitable. Similarly, there is a next example. It says acceleration depends on the velocity by following relation: a is equal to v, and at t equal to 0, x is given, v is given. We need to find out velocity at particular time, velocity at particular position. So for first part, a is given as v. Now we can use the a as dv by dt, which is v. After integration, you are going to get this as an answer. We know that dv by v is going to be ln v, then put in the value, we will get this as an answer. Now when we need to find the velocity as with respect to position, so we will be not using a as dv by dt, but we will be using a as v dv upon dx. This will relate v with x. Here we related v with t. So depending upon the situation, here x was imported in the second part. After the separation of variable, we are going to get dv is equal to dx, because we are getting cancelled out, and answer will come as 3 meter per second. So which definition has to be used?